also very easy to identify. Because of these points, we will use the definition of software architecture based on structures. Mr. Alhamdawi, yes, I will upload the PDF version of these slides on the ARSA website. I will upload these slides on the ARSA website. Okay. In our definition for software architecture, there was a phrase that said the architecture is a set of software structures. So in software architecture, we may have multiple structures, not just a single one. But what is the definition of a structure in a software? A structure is a set of elements that are held together by a relation. So when we talk about a structure, we want to see some elements, a set of elements, and also those software systems are just one single structure cannot claim to be the architecture of that software. We need multiple structures to clearly show and represent the architecture. One of these categories, and for showing the architecture of a software system, we usually use one or multiple structures from these categories. We will talk about each one of these categories in our course, so if you're not familiar with them, please don't worry, we will talk about each one of these categories of software architectures. The first category of structures is the module structures. Some of the structures can partition the system into implementation units. We call these implementation units the modules. So modules can be different types of implementation units. For example, you can call a function as a module, or you can call a class as a module, or a subsystem as a module. So the implementation units are called modules in the system. Modules are assigned specific computational responsibilities. So the computational responsibilities that are done by our software system is usually implemented in modules. And modules are the basis of work assignments for programming teams. We use modules to form our programming teams. Usually, for example, if we have 10 modules, then we can have 10 teams of programming, which is usually not like that, because we have the hierarchical structure and the hierarchical modules. So for example, if we have 3 high-level modules, we form 3 programming teams, and each one of these teams is responsible to implement the submodules of that high-level module. In large projects, the modules are subdivided to be assigned to sub-teams. As I said before, sometimes, most of the time, we have high-level modules, and each one of these high-level modules is composed of sub-modules. We can use the structure of these modules and the sub-modules to form our programming teams and sub-teams. The next category of structures is the component and connector structures. While other structures you focus on the way the elements interact with each other at runtime, as static structures, the component and connector structure is focused at runtime and how the elements can carry out the system's functions. We call these runtime structures component and connector or CNC structures. In our use, a component is always a runtime entity, so we see a component as a runtime entity. The component can support the system to be built as a set of services. The services and the infrastructure that they interact with, and the synchronization and interaction relations among them, all of them can form another kind of structure. This structure can also be used to describe a system. These services are also made up of the programs in the various implementation units. We call them modules. So different types of structures, for example, CNC structures and the module structures can cover different types of can represent different parts of the system architecture. The next category of structures, which are used to represent the software architecture, are allocation structures. Allocation structures are used to describe the mapping from software structures to the system's environment. For example, for mapping software structures to organizational elements or developmental elements, or installation elements or execution environment. For example, we can map between modules and teams. We can map the modules to our programming teams. We can assign modules to our programming teams to develop those modules. For example, we have 3 high-level modules and we also have 3 programming teams. Team number 1 is responsible for module number 1, team number 2 is responsible for module number 2, and team number 3 is responsible for module number 3. So based on the modules, we assign the functionality of developing those modules to our programming teams. Another example is to map the modules to the places in a file structure that are implemented. So for each one of the modules, we can specify a set of files or a set of tests that implement those files and those modules and test those modules. So we have a mapping between modules and between files. Another example for allocation is in the runtime. We can allocate each one of the components to be executed on each one of the hardwares. For example, we can identify the processes to be executed on the processors of the system. So there is a mapping between the components. This also can represent an allocation structure. Okay, before